grounding and other electrical safeguards. An electrical ground is a return path for a circuit. An electrical ground allows any spikes of electricity to be directed away from the circuit and into the ground where it's harmlessly absorbed. The primary purpose of grounding is to reduce the risk of serious electric shock from current that has leaked into an uninsulated area of an electrical device. If properly grounded, the leaking current will be harmlessly carried away. An electrical ground diverts excess current by means of wiring, thus bringing the current back into a circuit breaker. Grounding can also be through a rod or pipe actually carrying the current into the ground. Some common electrical safeguards are a circuit breaker, a ground fault circuit interrupter, or GFCI, or a three-pronged plug. First, circuit breakers. Circuit breakers are automatically operated electrical switches designed to protect an electrical circuit from damage caused by an overload or short circuit. Circuit breakers come in many sizes, small enough to protect household appliances and large enough to protect very high voltage circuits feeding an entire city. They all operate on the same premise. They must detect an electrical fault. Next, ground fault circuit interrupter, or GFCI. A GFCI is a device that shuts off an electrical current when it detects that that current is flowing along an unintended path, possibly through water or a person. It works by measuring the current traveling in both directions. Like circuit breakers, these can be manually reset. These are often used in wet locations or outdoors. Last, the three-pronged plugs. Three-pronged plugs have an additional prong which is known as the ground pin. This connects to an external ground when plugged in. This will divert an electrical fault to the electrical ground. Never break off the ground pin on a three-pronged plug. This removes a safety mechanism that is intended to be on the electrical device. A word of caution regarding grounds. You or a patient have the potential to become the ground if you come in contact with an electrical current and are in contact with the ground. This is a bigger risk if you're standing on a wet floor or if the patient has reduced resistance due to a break in the skin from a medical device, IV, or catheter.